if I were to imagine another isobar pattern that was in the form of a circle or a bullseye, whenever you have an isolated low pressure region with high pressure all the way around it, you normally refer to that in meteorology as a cyclone. Sometimes the word cyclone, it has other connotations. It may imply some kind of severe storm or a tornado or something like that. In the Wizard of Oz, when Dorothy was sucked up into the tornado, she was referring to that as a cyclone, right? Cyclone. But in meteorology, it has somewhat broader and less dangerous meaning. It's just a low pressure center with high pressure around it. And so I've drawn the isobars in this way. And let's imagine a parcel sitting there, kind of halfway out from the center. So there's high pressure here and low pressure there. So the pressure gradient force is going to be from high to low. So the red arrow is going to be the pressure gradient force, PGF. If it's to be in geostrophic balance, the Coriolis force must be equal and opposite to that. And the only way, given the properties of the Coriolis force, the only way it can have a Coriolis force in that direction is if the wind velocity was to the north, because then the Coriolis force is to the right of the motion vector. So I conclude by that reasoning that the air must be moving northwards, or I could say it's a southerly wind at that location. If I repeated the calculation there and there and there, here I would find that the wind must be blowing in that direction. Here I would find it must be blowing in that direction. Here in that direction. So in fact, the air must be going around the cyclone in a counterclockwise direction if we're in the northern hemisphere. Is that clear? So low pressure, cyclone, northern hemisphere, air goes around counterclockwise. We say that's the cyclonic direction. The air is moving cyclonically around that low pressure zone. But now we want to take a somewhat broader view of this, so I'm going to introduce, okay, this is a big jump, but I think we're ready to do this. So here's the equator. So northern hemisphere, southern hemisphere.